Measurement, dimension and vector, these are common to entire physics. Dimension is such an important chapter that off and on we have questions from this chapter, though the size of the chapter is not that big one, but you are likely to get questions in your competitive exams also. You must be having a ready-made table with you. There are many quantities that have the same dimension. Sometimes you find 15 combinations, 12 combinations, they have the same unit. For example, root L by G, root M by K, R, C, this L by, here it's written, L by R, root R by J, these all have the same dimension. So if you just fix in your mind that these expressions will have same dimension, then it will be easier for you. One time you remember, and that goes with 15 examples like stress, Young's modulus, bulk modulus, shear modulus, energy density. These all have the same dimension. It's given here. So that way we have prepared a table just to facilitate your study, and the rigorous labor that's needed will be minimized on the basis of this table. Also, there are some constants that you have to find the dimension, for example, G, capital G. So for that, simply you see, you'll use the equation, you'll separate G, this will be F R square upon M square. By putting the dimension of these all, you find the final dimension M minus 1, L3, T minus 2. This is universal constant. Once you say universal, it means it's applicable everywhere. G, small g, that's not constant, that's fixed value, of course, but on Earth it's different, on Moon it's different. When you say universal constant, it's not subject to any change basis of place, height, temperature. These are hardly material for universal constant. So these also must be remembered by you. Universal constant given here. And some quantities have no dimension, like angle, solid angular refractive index, coefficient of friction, relative density. So that should also be in your mind. From that point of view, you can avail this table.